Hello, hello, hello. It is me, Kamer, aka the Nerdy American in England, coming to you from Breadboard Studios headquarters, aka the Shit Shack, Southern England, more specifically.
Good morning, Glenn!
Right, we're going to do a VCO build. We were focusing on getting the MIDI to CV working, and then getting the PCB working on that. And then we got that working, so now we can double back to where we started, and then we'll do the repair after that of the Neo Geo Pockets. We're going to do the recap first. The repair we're probably going to do on a separate one. So about 2 weeks ago, we picked up that, which is a bench power supply. We did this because I was getting tired of screwing around with B-Nuke, and it was just a hassle and everything. So after I switched, all of our oscillators stopped working. And basically what happened was for 2 weeks, nothing worked. My filter circuit stopped working. My VCO stopped working. Everything quit working. I tore down the PCB, did a complete rebuild, still nothing. So I got to looking, and you got the yellow port on that thing, right? So what I assume is black and, is negative. Red is positive, and yellow is universally the sign for negative voltage. Apparently it's not negative voltage. Apparently it's ground. And what happened was when I hooked the scope into what I thought was the negative, it caused a ground loop and it blew the fuse. So unbeknownst to me, I repaired it, did it again last night, and it blew it again. So because that happened, we've got to build a negative voltage rail. So this is an ICL 7660. This is a DC to DC converter. What this does is whatever you feed into it, it will convert it into negative voltage. So if you feed 6 volts into it, you'll get negative 6 volts out. And this is like a recommended circuit, basically. So basically, we're going to build this. So we need the negative voltage to power the op amp because the VCO has an op amp in it. This is the voltage controlled oscillator that you're going to drive using the MIDI to CV converter. It's very simple. It's only got a handful of components. You can see here it's listed. It's got an LM358 dual op amp. You can really use any op amp that you wanted to if you're building a VCO like this, as long as it reads out just like this. As long as you got an inverting and a non-inverting, A and B, and then you need 2 outs, otherwise this won't work. So right now we're just supplying that negative voltage. So let's build that LM chip. So I'm going to share this on the side as well. So this is our new board. We're going to test this in a minute, but what we're going to do is we're going to build it up to 3. That way you can see what it looks like when we build out one of these VCOs from scratch. So right now we're worried about this one. This is that LM chip that we were just looking at, which is the ICL 7660. This is a converting power chip. All this does is gives us negative voltage. All right, so this is the one we want to do first. Okay, so this little cap here. So we need to go from pin 2 to pin 4. So that's pin 1. So we need to go from pin 2 there to pin 4 here. All right, so pin 2, pin 4, with the polarity to the right. Okay, so there's one of them. So that is this one right here. Okay, so now we need to do this second one right here, which is right there. And it needs to be backwards. There's ground, back there. Straight line, pin 5. Might actually go that way with it. Okay, so there's the 2 caps. Okay, so we got some wiring we need to do in there. That's got to go to ground, so that's pin 3. Let's do that one. Alright, so that's ground to pin 3. So all we need is power on pin 1, and then the output power comes on pin 5. So this pin right here, in between the cap and out, that's going to be the output for the negative voltage, and it's going to go right to that rail. So let's get the rest of these on. Alright, so we're going to jump that bridge right there. Alright, so same row, went over, boom. So there's that row there. So now we just need to run 1 over, we'll do 2 over, and then up to the rail. And then that's the negative voltage covered. Okay, so we're going to use yellow to signify negative voltage. Alright, so now we got this rail. This whole rail now is energized with negative voltage, so we can use it where we need. Alright, so this is all done. So let's build the first op amp. There's the op amp. Pin 1 is up here. I'm going to mark that just so you guys don't forget. Let's mark pin 1. Okay? So 1, 2, 3, 4, 5, 6, 7, 8. Alright, so that one right there, that's what we need to do first. That's pin 4. That needs to go to our yellow power rail, which is that one, because we got negative voltage. So we need to go from here to here, and then it runs that whole row. So let's put a negative power there first. If you're not going to be using a negative voltage, then you'll use just the negative on the battery or power terminal in place of a negative voltage, but I don't recommend it. So now we need the positive voltage, which is that one right there. Okay, So there's that one done. Okay, so here's where things get a little tricky. Now we're powered. Now we need to wire it out according to the schematic. That's your control voltage in, which is going to come from your MIDI to CV converter. That'll be the positive, and then the negative will obviously go to the negative rail. And then you got 3 pins here. You got one that goes to ground, you got your output, the middle pin, and then the out. So if you look at a potentiometer, you got 3 pins. That will be the control voltage in, that will be the output, and that will go to ground. So we'll do this one as input, this one is output, and then the other one is ground. So let's do the ground first. So let's scoot this down so we don't lose our place. So the first one's going to be ground, well, negative, which is this one here. There. Okay, so now our input goes here. So this needs to be the output. We need a 68K resistor. So we got to get from up here to down here, pin 2. So let's use the resistor. We're going to jump this bridge over here. So let's just plop the resistor down right here. Alright, so the output will output to this row, which goes through this resistor, which is now we're going to jump down there. So now this row right here is energized. Okay, so there's pin 2, over, up, resistor, there's the output. So now between the negative and the output, we need a capacitor. And this needs to be non-polarized. See, there's no plus sign. What do I mean by that? It either needs to be a foil cap, like this, one of these little boxy ones, or a cap without a stripe in it. I've got one here already, so let's just go ahead and do that one. So this is going to go from pin 1 to pin 2. And this does kind of matter where it goes. You can see the input goes in, so the cap is kind of after the input. So we need to put it behind the input. There's pin 1, there's pin 2, there's the input we put earlier, so let's put it behind it. So we're going to go right there. Pin 1, pin 2, boom. 10 nanofarad capacitor. So we need to go from pin 7 all the way around to pin 1. And we need to do it with a diode. And we're going to go around and over to pin 7. So we need to go from here to here. There we go. So now that's facing that way. That leaves 2 diodes right here that are opposing. So it needs to go from right here, that's pin 5, all the way over to here, pin 1. And it's got to be in the front. So this is where you got to be careful because the LED direction matters and they're hard to tell. So the longer leg needs to go on that side and the shorter leg goes on that way. There's the first one, and then we need to reverse the next one. So the longer leg will be on the second one, and the shorter leg will go on the first one. Okay, now this row has got both of these connected, and this row has got both of these connected going to pin 5. So they both now need to go across here to activate these 2 pins, and then we're going to jump all the way over to there. Actually, I may have to move this up one to make enough room because this is really important that this one's in the front, but it needs to be behind the diode. Placement's super important with these. Okay, so there we go. So now we're going to run it from here to here and then there to pin 1. So let's jump this one here first. Okay, so pin 5 through 2 LEDs, over, down, pin 1. That should be everything. Oh no, we got one more. We got one resistor in between op amp 2 inverting out to the output. Alright, so we got a 47K now between pins 7 and 5 behind the LEDs. Okay, that leaves us with one more and then we're done, which is the 1K output. So the output needs to sit in between the capacitor here and the first LED. So the capacitor's here, and the first LED is there. So it needs to go right here. That's our output. That's going to be our main audio out. Pin 3 goes to ground, middle pin goes to out, pin 1 goes to the input, just like that. So this is going to be our pitch tune. This is how we fine tune it. Okay, so the first one we need is regular power, not this yellow power, because the yellow power gets it from these 2 up here. So first things first, let's do normal power. Alright, so that's power. So now we need a driver. We need something that does CV. So we've got a kitten to do this, and we've got our BBS PCB, which is that one. This one's actually going out for someone. We're going to test it. So we're going to do a head-to-head comparison. Okay, so let's do the kitten first just to use it as a baseline. So this one's set up just like ours. You got a ground and you got an output. This one is the ground, and it's got to go to ground. No question about it. It's got to go to the ground on the board you're hooking it into. Okay, here's the input for control voltage. So it goes right there. That's going to go into our knob. Put that there. Okay, so now we need the output, which is going to go to our multimeter. So this is our positive on our oscilloscope. It's going to go to the output. Okay, so that's our output. And then we need a ground for the oscilloscope. And that should be everything we need to at least verify it for now. Okay, so it's powered up. Okay, so let's do a highest note check, just one solid note. All right, so we're sending a note through. So the oscilloscope, we should be seeing a nice, perfect sawtooth wave if we did this right. Oh, hooked it up wrong. Sorry, that diode right there is not supposed to go to pin 1, it's supposed to go to pin 2. So we gotta fix that, hang on. There we go. There we go, boom. Got a nice perfect sine wave. Nice perfect sawtooth wave, see? And if we turn this, we can adjust the pitch. See how it gets wider? So wider means higher pitch. Sorry, shorter means higher pitch, wider means narrower pitch. There we go. So if we change the note in Ableton, so if we play a song right now, it's just doing one note. If we switch over to this, which is like just a little test song, we can now see it changing pitch dynamically. It's happening really quickly, so the USB is kind of slow at keeping up with it, but if I show you my screen down here, hang on, see how fast it's changing? Nice sawtooth wave. So that's number 1, which we did. Let's just double check number 2 and make sure that one's all right too. So same output between the diodes. Yeah, so I got some scaling issues. It might actually be the LED. It could be the cap on this one. Oh, I missed a ground. That's why. There we go. That was the one we missed right there. There we go. Boom. Nice, perfect sawtooth with adjustable pitch. Let's go into recap mode because that's enough for now. Anyway, all right, let's start taking her apart. Did I actually get it off? I did get it off. Okay, cool. Sweet. Okay, so let's get the, what is that, the speaker? Let's get that speaker off there. There we go. Woo wee, that speaker's seen better days, hasn't it? Look at that. But you did send me a replacement one, so that's all good. All right, first things first, let's put this thing on the rotisserie and make sure it's safe. All right, so now it's safe. Now we can actually start messing with it, not worry about getting damaged. All right, first of all, that thing a little funky. So let's deal with that first. All right, let's give it the old rub and scrub. Ooh, button's pretty grubby too. I mean, this is the old unit. It's understandable. Shouldn't say it like that. I'll do the buttons real quick before we start doing the caps. All right, so you can change these buttons out. They actually do sell them online. What I'm gonna do is I'm gonna run some contact cleaner through them. I gotta get this one good. I use this on VCR mechanical buttons a lot and it seems to do a pretty good job. Feels better already, so that might have helped. All right, let's recap this now. Let's do this one right here, get a good start. Do an easy one. I don't want to force this one because it may have electro damage under it. Usually they come off quite quickly. If they don't, there's usually a problem. I'm betting this is probably where we're going to see some of the electrolytic damage if we see any. Oh, it did have a giant pad on it. They did do that to deter people. That's the weirdest looking pad under a Kappa I've ever seen. Look at that. It's got like a T-pad underneath. Do a nice scrub, just in case there's any electrolyte hanging around so we can neutralize it. Alright, let's do the next one. I bet they're all like this. No, that one's not. That's good. There's 2. God, that one definitely didn't want to come off. Alright, let's clean and swap these out. Looks like one of them got a bit grubby. That one down there. That one looks like it's got some electrolytic on it right there. All right, we got to pull this red one off and then swap it with a different one because it doesn't match what was actually there originally, and I don't trust it. Like a glove.
Like a glove!
All right, so there's one side done. Let's do the other side. Whew. God damn, that's a tight squeeze. All right, it's the last one. Shoo. Let's put it back together and see what we got. Oh, 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 first time, did you see that? Hang on, hang on. Screen's not happy. I might have to redo that ribbon. To start, looks pretty damn good. So why is it not one giving me a display? All right, one more try for the night. All right, so we got no video. We got a light, and we had sound to unplug the speaker, but okay, we're gonna take a break on this unit here. This thing's making my head hurt. So we're getting boot now, but no display. So I have a sneaking suspicion that the digitizer might have taken a hit when those caps went. Anyway, have a good night, everybody. Thanks for joining. Take care. Deuces.